we're going to do some problems using Newton's second law. First of all, Newton's second law, hopefully it came up in the lab. Acceleration is proportional to the net force acting on something. That was one part of the lab. A little typo here I didn't catch in time. This is supposed to say acceleration is inversely proportional to the mass. That was the second part of the lab. That was why you had to do that weird 1 over a graphing. When we combine those two statements, basically what we get is a new equation. You can combine them. Acceleration was proportional to the net force, so F net goes on the numerator, and inversely proportional to the mass, so mass goes on the denominator. The most common way that we write it is we flip the m to the other side, we get F net all by itself, and we can say that F net is equal to m times a. That's the math for Newton's second law. In the lab, we didn't have to worry about friction, so we just talked about force. If there is friction, that'll come into play in figuring out what F net is. If we look at this version of the equation, there's a cool thing here. Acceleration, whose units are meters per second squared, those units are equivalent to the units of force per mass, or newtons per kilogram. If you think of the 9.8 number, it tells you the acceleration of free fall and how strong gravity is. It's in both meters per second squared in one case and newtons per kilogram in another case. Well, let's try it in a problem, see how it goes. Oh, you'll notice I broke this into parts. We'll do a few at a time. For one like this is mainly just to practice the equation. We know that F net equals ma. 250 grams needs to go into kilograms. So if we know F net is 2, and the mass when we put it in kilograms is 0.25, we can solve for the acceleration. We flip the 0.25 to the other side. Dividing by 0.25 is like multiplying by 4. We get an acceleration of 8, and the proper units are meters per second squared. Let's try another one for practice. Same idea. The mass was given in grams, so this means the mass is 0.5 when we're in kilograms. It says that it's accelerating at a. We want to know the F net. So again, just to practice, F net equals ma. The m was 0.5, the a was 3. By the magic of the metric system, we end up with an answer in newtons. It happens to have the value, of 1.5 newtons.